Ladies and gentlemen, boys and girls, thank you all very much for coming. It's 1700 hours here in the UK, it's 1900 in Tel Aviv, and it's 9 a.m. on the West Coast. So good evening, good night, and good morning. My name's Martin, and over the next 30 minutes or so, I shall walk you through advanced messaging capabilities in diffusion. I will introduce the concepts, and then I will show them working. This webinar is a series of webinars, each tackling a fundamental feature that a developer will likely encounter in their development of a solution. I invite you to put your questions to me via the Q&A feature, and we shall answer them throughout and especially at the end of the presentation. The more questions, the better. On a personal level, I'm really happy to introduce this feature as it's sometimes overlooked in favor of pub/sub, and that's a shame because there's a lot of fun to be had with this and a lot of problems to be solved with the using of it. So let's get the ball rolling. What is this video about? We're going to cover the request reply messaging feature of Diffusion and Diffusion Cloud. So why is this useful? Recall that in a previous webinar, we covered Diffusion's pub/sub feature, which is the stateful one-to-many communication feature. When using the messaging feature, we can use stateless one-to-one and many-to-one messaging. We shall go over its advantages over existing technologies such as REST. So specifically, what are we going to learn? We're going to cover how to send requests and receive responses. To make things complete, we shall also cover the server or back-end side or back office side, where we will receive requests and send responses back. We'll see some popular use cases for messaging and explore at least one for each of the three modes of addressing a request. It's important, that number 3. It's the magic number. Then, not to brag, we shall explore genuine reasons that messaging is better than the alternatives. So how's this going to work? Well, mostly it's going to be hands-on. There will be a few slides to introduce concepts to set the scene, but mostly we're going to explore a working example of a foreign exchange trading app that puts the messaging features to work. Feel free to try out the same features in using your own free Diffusion Cloud service. Firstly, let's recap a little. So that we're all starting from the same place, this is Diffusion. There's a single server in this example, but more often than not, they run in a cluster. Clients interact with the Diffusion server via a session, and here at the edges are some clients. When using the pub/sub feature that we've covered in previous videos, clients subscribe to a topic. When data is published to a topic, the Diffusion server pushes an update out to all of the subscribed clients. The notable features of this communication pattern is that its clients do not directly communicate, but instead via a piece of state held on the server, the topic. Also, for typically one publisher, there can be many subscribers. This is a one-to-many communication pattern. There are many use cases when we don't need stateful or one-to-many communication, for which the messaging feature is ideal. Using messaging, clients, or more accurately, their sessions, can send a request directly to other sessions, and for every request, there is a matching response. The client receiving the request does not need to know where to send the response. That's taken care of by Diffusion. So we can start to imagine how this lends itself naturally to implementing services. Buy this, order that, approve the other. In common with Diffusion, both the request and the response are compactly encoded in CBOR, which is an open standard. There is an RFC for it, and it can be compressed. But unlike pub/sub, there's no deltas. There's no state to compare it against. There are 3 ways of addressing your message, and we shall cover each of these and their likely use cases shortly. We shall also see each of them being used in a real foreign exchange app and study the real surrounding code, the good stuff. It's important to cover this fundamental point. Pub/sub and request response are different communication patterns. Let's visualize it. This is pub/sub. The subscriber subscribes to data that the publisher holds, and thereafter the publisher can publish new data, each delivered to the subscriber. Typically, there are many simultaneous subscribers to a single publication. In contrast, request response is far simpler. A single request is sent, a single response is sent back. So we know that every request begets a response. The messaging feature gives us three means of addressing your requests, and they are to path, and here's how you would call it using the JavaScript API, and we're going to see real uses of that shortly. To session, notice the similarity in the calls. It's just an extra argument. And to session filter. Let's start with to path. This addressing mode, which we call to path, as the sender addresses their request to a path on the server, such as my FX trade order. So the client sends the request to a path. It does not know where it's going to go beyond that. Paths are also used to identify topics. However, messaging and topics use separate path spaces. So it does not matter if there is or is not a topic that also uses the same path. It's just a handy means of identifying the message subject. Once the server has received the request, it routes it to another client, which has previously bound a handler to that path, permission allowing to handle incoming requests. Many clients can bind handlers at a path, and the load of requests is balanced across the handlers. This is a great way of hosting and locating a service, the sort of thing we might do with REST, and we'll cover shortly the advantages of messaging. Permission allowing any session, even ones running client-side, can bind handlers to a path. More flexibility makes for more use cases. Every client connects to the server through a session, and every session has a unique session ID. If we have the session ID for another session, we can address the request directly to it. The API makes it simple. We send a message to a path and an optional session ID, in which case the message is addressed directly. In both cases, a handler in the destination client executes and sends a response. Finally, and most interestingly, we can address a request to a portion of your audience with an expression that we call a session filter. It's a whole DSL, it's covered in the manual, and it's used in other features as well. In contrast to other modes, this means that one request can be sent to many sessions, and for each request, there will be a matching response. So for example, this filter could address a single request to be delivered to every session held by an authenticated user using principal is some user, or address a special offer to your premium customers with tier is premium. Each of the many responses is delivered back to the requester, so we can gather them and we can count them, so we know how many times it has been delivered. This is great for transmitting targeted special offers or delivering messages to a user, regardless of how many times or where they're logged in. But why not just use REST? I mean, it's a good question. REST is everywhere. It's understood, and if it ain't broke, well, to start with, less is more. A diffusion request is compactly encoded in CBOR, so a request containing a JSON payload will compact down to a handful of bytes. And in the code example we're going to see, I measured a request of 118 bytes of JSON and the protocol header, compacting down to 113 bytes. Try to cram an HTTP header into that. Don't take my word for it. Open the Chrome DevTools and measure for yourself. They are absolutely tiny. There's also the complexity of correlating your RESTful data to the rest of your solution. We had a real customer contact us last year who were using Diffusion to deliver their data in one hand, and with the other, they were receiving trade requests using Amazon AppSync. And this originally they contacted us because Amazon AppSync or AWS AppSync then had problems with firewalls that did not allow WebSockets. And they wanted to find out if they could do messaging with Diffusion. And the answer was yes, they could, because Diffusion has an HTTP long pole fallback and would still function in that circumstance. It would not fail silently. But the unexpected payoff was that they did not then have to correlate the communication with one of their customers, which they'd made with Diffusion, and all the other communication which they received using AppSync. They didn't have to correlate them back together. They didn't have to figure out the session principles. It made things simpler, as well as being more effectively communicating through shonky firewalls. So to our next point, HTTP is synchronous mostly, though HTTP2 promises to improve on that. However, it can suffer head of line blocking. Once a RESTful request has been transmitted over a TCP or a TLS session, that session will sit idle until the response is delivered. Diffusion messaging, however, is fully asynchronous and nothing is held up. If your HTTP transaction needs it, establishing and authenticating a new TCP or help you a TLS session is costly and subject to slow start congestion control. Oh, on top of that, you've also got to authenticate it as well. So it's relatively slow to establish and slow once it gets going. By the time we've exchanged the SSL certificates, we could have sent your request via the Diffusion session several times over. In that line point there, I refer to as a hot TCP or TLS connection. What I mean there is that the connection has gone past the stage of TCP slow start. So it will be nice and fast and hot, and the data will go as quickly as it can. Finally, RESTful requests are handled on the back office only, at the back end only. If we need to turn the architecture on its head and handle requests in the front end, you've got a challenge on your hands. Imagine how you would otherwise quickly gather an opinion poll from your audience, or distribute a piece of work for some crazy web-scale MapReduce, or more applicably, more practically, gathering client-side logs for central gathering and analysis. A RESTful solution would have to poll, but a Diffusion request handler doesn't care where it is. It just needs a Diffusion session. So we're nearly at the good stuff. I'm going to walk you through an FX trading app where the front and the back office use all three flavors of messaging. Firstly, we're going to start the process using send to path messaging. The trading front end will send a message to a path, which the trading back office has bound to a handler. That trading request will be buy me this or sell me that. The back office does some basic validation of the currency, the user, and the price, and it will send back a response, and it displays the request and records the original session ID for later on. Next, we used send to session messaging. When the back office user decides that the trade can be satisfied or not, we send a message to the session ID for that trade. And finally, when the back office needs to communicate with all sessions for a user, it uses send to filter with a simple session filter. So enough of the slides. But before we get to the good stuff, let's stop and see if we've got any questions. We've got no questions open. Okay, good. Hope you're taking notes. What we have on the left-hand side is a foreign exchange trading app. Here on the left is our table of currencies. It's a live table. This is real data that was recorded earlier on this year. It's about 4.5 hours worth of it. So I think we're good for a half-hour demo. And we can see that as the data rolls in, and this is all done over a single diffusion session. As the data rolls in, the prices change, and they will animate. They will flash green or red depending upon whether the price has gone up or down. And you'll notice occasionally that the high or the low will change as well. And we covered this in the previous webinar on PubSub. This is pure play pub sub that we're reusing. What we're going to do now is imagine that if I would like to start bidding on currencies, then there I go. I'm going to buy some GBP USD. That's the price. And I hit send. Oh, gosh, made me think for a moment. And we get back a response that it's the request, the trade request has been received and it's been acknowledged and it's okay. But what it hasn't happened yet is it hasn't yet been satisfied. It's gone into the back end, off into the land of matching engines, where the trade will try to be matched up, usually bulked together into a larger trade, which can be matched up with another larger trade, and then they can be taken apart again, and people can be told. So we don't have a matching engine, but instead what we have is me with my buttons, which I can click to say whether or not it's been satisfied or not. And following the happy path, this is what we're going to do. I'm going to say, yeah, this is a good trade. We're going to make that happen. And that was, in the first place, that was sent to path messaging, and then it was sent to session messaging. And we'll dig in to see the real code in a moment. But let's play around. We'll have a little bit of fun, first of all. So I'm going to take that one there. I'm going to change the currency. Doubloons. Yeah. I get a message back. No, doubloons is not a valid currency. Or if I pick a valid currency, I'm going to change the prices to something completely unacceptable. Oh, that one's acceptable. So the backend will keeps a history of the last 60 seconds of prices for that particular currency, and will check to see if it falls between the highest and the lowest recorded range for that particular currency. And in that case, clearly it did. So let's try to be more exceptional. Let's change that end instead. And no, unacceptable price. And that text will have been echoed back from the back end to tell us that the front end is asking for something that it is not going to get. Next thing I'm going to do is I'm going to log in as a different user. Let me find my code for that, where we establish our session. Here we go. So this is live code. We can actually change this and alter it. We're logging in as user Jack here, and user Jack specifically has a role of trader. If, however, I log in anonymously, now we can still get our prices because there's nothing to prevent us doing that. There's no permissions we need to get these particular prices in this scenario. But if I try and buy and sell, I'm told that my principal lacks permission. Indeed, there's another. We can see the on the right-hand side, this is the register of attempted trades. We've got the trader's name, and the trader was called Jack, as we can see, but this one, the trader was anonymous. See the timestamp, the currency pair, bid price, essentially just a visual record. Now, let's log it back in as Ted now. Ted and Jack are two users. They both have the role of trader, just using standard diffusion authentication. Yeah, good. Right, so there's another trade that was exception that was allowed. So let's allow that one, and we'll allow that one. Okay. So there's been a bit of activity. What I'd like to do now is send a message to, in this case, to user Ted, to tell him, let's say, for example, your credit is good. And this will be delivered to all sessions where Ted is logged in. So let's get ourselves another tab, another browser for this guy. We should be able to see messages from back office. Messages from the back office. We're logged in here as the same user. The back end here does not know how many times Ted or Jack are logged in. It doesn't know, it doesn't want to know, it just wants to know that I want to send this message to Ted wherever he's logged in, because he's making lots of trades and he's doing lots of business for us. Beg your pardon, it's Jack who's logged in here. So there we go. Send the message. And that got to Jack, begging your pardon. Let's log in here as Jack as well. And still good. There we go. So the message was delivered to both this session and this session, even though the backend didn't know where Jack was logged in. It just told the server to take care of it. Okay, right. So enough blinky lights. Let's have a look at the good stuff. Let's have a look at the code, because that's what we're all here for. And there's 3 modes of communication we want to talk about here. There is to path, to session, and then to session filter. So let's talk about the first one. We're placing a trade where we send a message to a path, and that's done with this function here called submit trade. The whole thing is written here in JavaScript. More typically, in a business scenario, the backend will be written using Java or one of the .NET languages. But we're using JavaScript here for 2 reasons. First of all, typically half of your solution will be written in JavaScript, and the JavaScript API is fully fledged. You can do all of the front end and all of the back end things with it. Don't differentiate. It's a tier 1 SDK. And secondly, observable makes a great platform for demonstrating these things. I can demonstrate the front end and the back end using the same language in the same web browser, and also really drives home the earlier point that you can implement real business logic inside a client rather than having to have that in the back end, as is often usually the case. Anyway, enough yammering. Back to the code, which is the stuff we're all here for. This is submit trade, which when it's clicked, it's given the form. It will gather the values from the form and build us an FX trade object, which is an immutable object. Once it's built, cannot have its values changed. And that's handled in another note, another notebook. Then we pass that into the user interface, which throws a wrap around it. And the user interface is what we see here, these things, these rows here, and wraps the controls and the callbacks on them. Then we actually send the request to the path. So the path here is my FX trades. You'll see that pattern a lot, where we define a constant path at the front of the function. So we're sending to a path, and we're just expressing this object as JSON, although it'll be then compacted down to CBOR. Then we wait for the response we get back. We'll do a bit of logging. And if I open up the debug tools, you'll see the logging inside there. Then we dig inside it. If there is an error property, then we will tell the user interface that this went wrong. And that's when you get the big red cross. Otherwise, you get the big red cross, and you also get the text of that as a tooltip. And then, but if it's succeeded, you just say true, and then you just get the big green tick, and everybody's happy. So that's sending a request. It's not a lot of code. In fact, the sending of the request is about that much, is about 4 lines of code. Maybe 5 if we include gathering the response as well. Gathering the response, of course, we use async await, which makes life very civil, gives us the illusion of writing synchronous code, although it is strictly speaking asynchronous. Let's jump over to the back office on the other side, where we use handle by cell requests. Here we go. So there's 2 pieces to this. First of all, we're handling messages sent to a path. We call here add request handler to a path, which is also my FX trades. If you're used to taking requests on or accepting sessions on a TCP socket, this is kind of analogous to that. Kind of. So we bind our handler to a path, which is textual. And this is the thing that we bind. There's an error handler, a close handler. But the interesting bit is on request, which we've broken out into a separate function handled by cell request. Okay, got three arguments: the object, the request that it's delivered, which we have to deserialize and turn into an object, the context and the responder. The responder is the thing we respond with. We'll see its use later on, and the context has some interesting stuff in it. The context has, in this case, has all of the session properties. In fact, let me just backtrack a little bit here. There's two arguments to add request handler. First of all, there's three arguments, excuse me. There's the path, there's the actual handler object itself, but there's also this constant here, all properties. All sessions have properties associated with them. And by passing in all properties here, we're saying that the context object, when a request is delivered to me, I want to know everything about the session that sent it to me, principally so I can then find out who sent it to me, so I can update my user interface with the name Ted or Jack or what have you. So we get the request, we deserialize it, and we build ourselves an FX trade object from it using the same class as before, server-side, client-side, code sharing. We get the principal value out of there, and that will be Ted or Jack, or will be the empty string for anonymous sessions. And then we also have the roles of that user, which is good, because using the roles, we can then find out if that role, if it includes the trader role, which is a role defined in the in Diffusion, in our Diffusion Cloud instance. In fact, that we're using Diffusion Cloud here rather than anything local. So we're going to add our trade to the user interface. There's the trade object. We get some additional information, which is the session whence it came, and also the principal, the user. And then we start to implement our basic business logic. Is this guy a trader? Does roles has traders? Roles we parsed here from a comma separated string CSV into a set, into a JavaScript set object. So we can very easily find out, does this role, does the set of roles have trader? Because if it doesn't, then we'll write back. And we've seen this message already, principal lacks permission. And we'll respond back with an error object. Then we checked the check for a valid FX pair name. This is why it doesn't like doubloons. And then it'll go on to check for a reasonable bid price, because the backend is also subscribed to the same set of data. Although it's not visualizing it, it is subscribed to it, and it is building up a history for those currency values. And like I say, it keeps a 60-second history for those prices as it rolls in, so it can find out what's acceptable, what's not. And then if it's passed all of those tests, it will update the user interface, and we see the big green tick. We also send back a response back to the front end, so it can update its user interface and display a big green tick. So that's part 1 of 3. Let's move on to step 2, which is sending the satisfaction message, which we will do with sending message to a session. Now, we're still in the back office here. I don't like to use client and server here because the terms are unhelpful, because we have certain reinforced stereotypes about what clients do and what servers do. Both of these guys are peers, and they're sending messages back and forth. They happen to be running in a web browser, which is often associated with client-side technology. But in this case, they're both peers. So what we're looking at here is the back office and the front end. So still here in the back office, the function that's called when we click one of these is send satisfaction. Firstly, we define the path, myFX trade satis. Could be anything, to be honest, but this is what we've chosen to be consistent with the rest of the implementation. We compose the thing that we're going to send. So there's our FX trade, and the action, which I think will be accept or deny or satisfy. It's some string enumeration. And then we send the message to the session ID. So it's the same function as before. It's send request, path request, but also the session ID. So we're telling the server, don't send this to a path handler on the server. I want this to go directly to that guy over there because he sent it to me just like a minute ago. This is handled on the front end by handling messages sent to this session. There we go. So there's our path again, myfx trade status. And this is our handler, which has been bound using set request stream. So whenever a message arrives, a request and a response, the term message becomes murky and loses its clarity. So when a request is delivered to us on path myfx trade status, it is handled to on request, which we can see right there. And we're immediately going to write back saying, okay, that we got it. But we'll then take it apart. And if the action is equal to accept, then this will evaluate to true. But if it's not accept, that of course will be false and updates the user interface accordingly. This is the trade ID. The trade ID is this thing here. I did use GUIDs to start off with. They're just too long. They take up too much space and they just make the user interface. This is, to be honest, even kind of unwieldy, but gets the message across. Every trade has a unique ID. And we use that ID here to update the user interface and say the trade ID ABC123 has or has not been accepted. So we've made, so that's the second part of the second messaging mode. We have sent a message to a path and got a response back, and we have sent a message to a session. The third part is sending a message to a user, for which we use sending to a session filter, and that's done again in the back office by a function called send trader message. There we go. Send trader message. So this is driven by the user interface. And if you want to, you can have a look at this code. It's free. It's public on Observable HQ. You can fork it and play with it. But this is driven by the user interface, and it calls it with the trader principal, TED, JAG, admin, what have you. And the message that we actually want to send them. First thing we do is define a path, which is different because we're going to be sending messages again to the front end, and it needs to know what exactly are we talking to the front end about. And this is the subject of the conversation. myfx trader message. We're sending a message to the trader, to the actual human trader who's sitting in front of that screen with his eyeballs or her eyeballs. This is the interesting bit. We build a filter. In this case, it's dollar principal equals trader principal. There is a lot of power in a session filter, and we're not really doing very much with it here. We're barely scraping the surface. If you're curious about them, I encourage you to dig into the examples that ships with the product, and the manual has a good section on it as well. But I think this is fairly clear. We want to send this to all sessions where dollar principal, so the username, equals some string. And there's the request as well. There's the actual text. Not much more to it than that. We're using JSON here. We don't have to, but we're using JSON here because hey, JSON and JavaScript go together so well. This is our message callback. We'll dig into that in a little bit. And then we send our request to the filter. There's the filter. That's the path. The actual request object itself. So that's going to be received by the server and then fanned out. That's going to be repetitively delivered to each of the matching sessions that matches that filter. And when a response comes back from any of them, the response is delivered to this guy, message callback, specifically to on response. And we're told that a particular session particular session ID, excuse me, responded with this thing. So we're not doing much more than logging it. We could count it. So we could actually put a little badge on the user interface to say, oh, this was been delivered once or twice, or to 3 discrete sessions, or 0 sessions. That would be useful to know that actually this guy's already gone. So we've got to take a different action then. So that's sending the message to the filter. Let's see how we handle it. And it's down here, handle trader messages. And in fact, this code here, handle trader messages, and this code up here does look kind of similar. So we set, let's start with the path. Let's start at the top. The path is the same, so it's my FX trader messages. Here's my handler object. And here we are binding the request stream so that this handler handles messages on that particular path. And there's the handler. The most interesting part is on request. So when the message is received, well, specifically the message, I must stop calling them messages. When the request is received, we deserialize it. Well, the first thing we're going to do is, because we're going to respond back to the other guy saying, yep, got it, working on it, thank you. We're not going to say anything other than yeah. So we may as well say that sooner rather than later. We'll deserialize it. We log a few things, and then we update the user interface. I could have abstracted away, but for 3 lines of code, it's fairly straightforward. Handle trader messages is given the table body that we're going to be inserting it into, and it inserts a new row, and then composes a row with 2 cells. The first cell has the timestamp, and the second cell has the actual content of the message itself, and that's it. And we can see the values there. There's the timestamp, there's the actual message as well. So there we go. That is there and back again for 3 different messaging modes. Okay, so let's pause and take for questions. Oh, excellent. We got some real questions. Excellent. So Alex asks in his message, you're using JSON in your examples. Can you use other data formats? Absolutely. Yes, you can. I'm using JSON because it's extremely handy, and JavaScript and JSON go together. And indeed, JSON derives directly from JavaScript, as we all know. But the messages, of course, are transmitted not in JSON, but they're transmitted in CBOR. And we can use any of the fundamental diffusion data types when we're communicating, sending requests or responses. And they include JSON or string or double or int64 or binary. Binary, of course, you can fit anything into binary. So yeah, you can. You're not limited in any fashion as to the data you want to transmit back and forth. It's not transmitted in plain text. It's not encrypted, but it is encoded in CBOR. So the amount of space that it takes can shrink considerably. And if the transport it's working on is compressed, then it can shrink down even further. Okay, what happens? Alex goes on to ask, what happens if messages cannot be delivered? Okay. So if a message can't be delivered, we saw in the various callbacks that the functions that we're told that they can't be delivered. In fact, let's just be brave. Let's go back to the code and actually have a look for ourselves. When we send a message, let's send a message. Here we go. So this is how it's handled in when we send a request to a filter. We're told when we get a response, but we're also told when we can't get a response. And that will happen for a couple of reasons. And the most popular being that either the session in question has concluded, has terminated, is going to be no more. But also possibly because of a business logic mistake, and the session that we're trying to deliver a message to does exist, but they haven't bound a handler to the path that we're using. Shouldn't happen, but it's in both cases we're told what's happened. So yeah, and if we're sending messages, just simple requests, we get a very simple, very similar thing. So here we go, session messages send request. We're using await there, so that will throw an exception which we're catching. and we'll be told that in this case, we're trying to send to a path. If, for example, there is nobody listening at that path, then the function call will fail and an exception will be thrown in turn. So at that point, you can take remedial action. Okay. And somebody asked, do you need a handler for responses? No is the good news. No. So handlers are good for handling requests. A response you do not need to handle. The handle is delivered to the transmitter of the request. So you only need a handler if you're intent on handling requests. That's the best way to. So you can kind of think of them as request handlers. Okay. And another question, they're coming and thick and fast. Gosh. So what properties are delivered by default to a message handler? Right. Well, none is the answer. By default, no properties are delivered to a message handler unless you ask otherwise. And we saw in the coding example, we said we wanted all of them. But more typically, we'd be a little bit more parsimonious than that, and we probably we just say just that one and that one. Session properties, it's worth taking a diversion into. Session properties are a very useful way of describing a fraction of the audience that you wish to address. There are the set of static session properties. So you saw us use dollar principal. Anything starting in dollar is ours. We give it you. So dollar principal is the user with which they logged in. But when a session does authenticate, you're free to give the session additional session properties. And there are things like, for example, service tier or spoken language or favorite sports team or left or right-handedness, who knows? So that it's up to you. And so if you wanted to send a message to everybody who's using an Android phone in, let's say, Scotland, then you could do it relatively straightforwardly like that. So long as the Android phone users in Scotland also had a message handler bound to that path to handle those requests when it comes in. But I'm going off into the weeds there. But the reason that we don't deliver anything by default to a session handler is to keep the payload down, because we're all about penny pinching those bytes to keep the size of the messages small. And the smaller the messages, the more of them you can push around, and the faster and the bigger the audience you can address. So unless you need them, we don't give them you. But if you do want them, we're happy to deliver them. Good. Oh, right. So we got another question from Josh. When sending to a session filter, all handlers respond. Does the sender get a list of response objects, or does it get a response before all handlers have responded? Yeah, good question. Right. When sending to a session filter, do all handlers respond? Do you get a list? What you get is multiple calls to your callback object. So if you wanted to agglomerate that, you'd need additional code on top of that. But yeah, if imagine that you send your center filter and you send to 100 people on a trading floor, and they may take time to respond. So each response is delivered immediately. That it is transmitted, and so you'll get multiple calls back to your response handler. So when it comes to processing them in batches, that's an interesting, but it's a separate question. Okay. See, oh, right. Okay, good. Right. So no more questions as far as I can see. Okay. So that's a wrap for today. Thank you all so much for coming. We covered the 3 modes, or is it 3 modes of addressing a request response message in Diffusion: to path, to session, and to filter. We tried it all out, and I've left my code up there so you can all try it all out if Observable doesn't throw a spanner in the works as it did mid-demonstration today. So you can try it all out at this address. Be sure to subscribe to our YouTube channel and click the bell to get the notification of when the next video is published, because all of these webinars are going out onto YouTube about 24 hours later. For now, however, have a great Christmas break. Stay safe and come back and see us in January 2021 for my next webinar on Diffusion's time series features. Thank you.